Hello there, Honors Algebra 2. Welcome to Lesson 3.6 on using the quadratic formula and the discriminant. I'm coming to you here from the basement of my older brother's house in Portland, Oregon, where I've been called upon to help out with some babysitting duties this week. I had a nice long weekend visiting my girlfriend's father up in Lake Chelan, Washington. And to get from one to the other, I had to drive for about 7 hours today. So it's midnight, I'm very tired, and I hope that this lesson makes sense. Good luck to me and good luck to you listening to it. All right, let's get into it. So to start off, we want to talk about what the quadratic formula is. So to solve any quadratic equation, you can use what is called the quadratic formula. That is right in the middle of your screen there. It says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You may have learned this already. You may have heard it sung to the tune of Twinkle Twinkle Little Star, I think. Let me give this a shot. It sounds something like this when somebody sings it to you. They go, negative b plus or minus the square root b squared minus 4ac all over 2a. So whatever tune that is. Anyways, that's how I learned it. Somebody taught me that song. They made me sing it for a while. Now I've got it stuck in my head whenever somebody mentions the quadratic formula. Now, if you don't want to just memorize it based off a little song, you can try to figure out how to solve it yourself. So if you have a pencil and a paper, I would recommend you pause this video, and what you try to do is you try to start with that equation. The first equation you see there, the standard quadratic, ax squared plus bx plus c equals 0, and you try to rearrange it to get x by itself. So if you're feeling brave here, like I said, pause the video and see if you can, on your own, get from one form of this equation to our final form, that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Give me a moment to pause the video here. Okay, if you pause the video and you have now unpaused it, it's for one of two reasons. Either you have successfully made it to the end, or you have hit a roadblock. So I'm going to walk you through the process that I found when I was trying to do this myself last year, trying to refresh this idea in my head to see if I could do it. So let's make this screen a little bigger, and hopefully that's big enough. All right, so we start out with ax squared plus bx plus c equals 0. Now, if I'm trying to rearrange to get x by itself, I would get anything without an x on one side. Moving on from there, you could try something. My first instinct is to try to factor out an x. If you do that, you might think to try to divide by x to get rid of that one over here. You end up with kind of x's in two different locations, though. We end up with an x on one side and x on the other side. If we didn't divide by that x, we still have a problem of two x's on one side, keeping in mind that we are trying to get x by itself, just one x by itself, at the end of this process. We want to solve for x. So if we have two x's here, that is definitely an issue. So let's talk about some things that you could try that look a little different than that. I personally like those little box diagrams. I'm a big fan of box diagrams. So what I did when I was trying to figure this out is I took my equation here and I stuck it into a box diagram. I thought, could I figure out how to factor this, take this sum and turn it into something that I could use my box diagram to rearrange and find something that looked differently. So my thought was, if I make this box diagram and I put my ax squared in one corner, maybe I can find factors that would multiply to give me ax squared. Well, one thing I run into is there's not just one way to do that. So we could have x times ax, we could have x squared times a. Either one of those would get me ax squared. And depending on how I wrote it, that's going to affect what ends up in these boxes. So I can kind of see that that's going to lead to a lot of different things to guess and check. And what I'm going to do instead of that is I'm going to take one step further before I use my box diagram. I'm going to divide everything by a. So dividing this term by a gets rid of the a. We put a on the bottom here and here. Now what this does, you will see in just a moment, I now am going to use this x squared plus bx over a to try and get somewhere. If I'm going to get x squared. I could get that from the x times x. And if I'm going to get bx over a, what I'm thinking is it's going to show up in two locations, and it's going to be the sum of these two corners. So if I want to get bx over a, I'm going to have to get half of it here and half of it here, which I could get if I multiplied x by b over 2a. So if you see x times b over 2a would be the same as bx over 2a. You would have x and b being multiplied on the top of the fraction. You'd have the 2a on the bottom, which I've written slightly different. Okay, so here we have it as 1/2 of bx over a, but you'd get the same thing if you multiplied x by b over 2a. Okay, so hopefully you're making sense of why that corner is what it is. Now, what do we get in that bottom right corner? We get something that we didn't want, right? If I multiply b over 2a by itself, I get b squared over 4a squared. So that's a little bit extra that I didn't want, but we'll figure out what to do with that in a moment. This is related quite well to your last lesson, which was called completing the square. And we're kind of doing that right now. We're working with completing the square ideas. Now, if I have x plus b over 2a times itself, I have x plus b over 2a squared. And I have seen that that results in everything in these four boxes, which is an x squared, a bx over a. When I add up these two halves of bx over a, I get just one whole bx over a. And I get this corner box I didn't really want, but it's there anyways, that b squared over 4a squared. Okay. Now, if we look right here, x squared plus bx over a, we saw that somewhere else. We saw that at the beginning. When we rearranged our equation, we got x squared plus bx over a equals negative c over a. So I'm going to replace that x squared plus bx over a with negative c over a. That is going to show up right here. Okay, kind of flip these around. So these two terms became this term right here, this negative c over a, and the b squared over 4a squared stayed there. Nothing changed about that one. Okay, now that we've reached this step, I want to put these two terms together. So they don't have the same denominator right now, but I can make them have the same denominator. We can multiply this fraction c over a by something that is equivalent to 1, which in this case, what we would do is we'd multiply the top and the bottom by 4a. So we'd end up going from c to 4ac, and we'd go from a to 4a squared, multiplying both the top and the bottom by 4a to get from this fraction to this one. Now the beauty of doing that is now we have a common denominator, and we can put them all together here. Okay, so going through those steps, we now have x plus b over 2a squared. Okay, right? This times this gave us everything in this box, which we have rearranged now into one term, b squared minus 4ac over 4a squared. Now, I want to point us to this. Our goal in the end was to get x by itself, and now I have one x written in this equation, so that's a good sign. Okay, we're going to go to the very end of this process, which is on the back of one of these little cards. Okay, so I'm going to take the square root of both sides. I end up getting rid of the parentheses on the left side. Sorry, I smudged it right here. That would be x plus b over 2a. And if I take the square root of the right side, square roots have two solutions, a plus and a minus solution. So I get plus or minus the square root of all that stuff that was on the right side, b squared minus 4ac all over 4a squared. Okay. Now, if I want to simplify the right side, the square root of the bottom half of the fraction is kind of easy to see. It's 2a, so 2a times 2a would be 4a squared. And the square root of the top, I'm just going to have it written as is. I'm just going to write the square root of the top of the fraction. Okay, my last step, I'm going to get rid of this b over 2a on the left by subtracting on both sides, which gives me a negative b over 2a on the right side. And since I have two fractions with the same denominator, common denominator, I can combine those, and I can finally write it as just negative b plus or minus the square root of b squared minus 4ac, and all of that stuff, the left side and the right side, were both over 2a. So now we find our quadratic equation. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And there we go. That is our quadratic equation. There are a few steps in there. I think the most complicated one is just seeing that you can replace this part right here, these first two terms, with negative c over a based off how you rearrange it at the beginning of the problem. Now, lucky for you guys, you will not be held accountable for that entire process. However, I think hopefully you can feel better. You can always feel better being given the process that gets you to these equations rather than just being given the equation and told to go run with it. So hopefully you can use those equations now feeling a little bit more confident. There is a process, takes about a couple minutes to go through, but there is a process that gets you from that initial ax squared plus bx plus c to our rearranged equation solved for x, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So all goes well until I have to end the video. All right, here we go.